So what is mobility of charge carriers? Yeah, so we know that all the electrons will get drifted towards the positive terminals. So how easily, yeah, so how easily you can say that it will get drifted towards that positive terminal? So that is what we sometimes call as a mobility of your charge carriers. Yeah, so how easily they can just modify themselves and they will just move towards that positive terminal. So this is about your mobility of your charge carriers. Now we will study what is the mobility of your charge carriers. We have seen in drift velocity the velocity with which the electron moves towards that positive terminal. So that is what it is, nothing but the drift velocity. Now what is this mobility of your charge carriers? So that we will study over here. So this is how I have just shown this free electrons within this your conductor, and they will all get drifted towards the positive terminal. Yeah, fine. So this is how we can show. Now this mobility, again we just simply say that, so this drift velocity is directly proportional to the electric field which is applied across this your terminal. So this ratio we can say that Vd is equals to mu into E, and this Vd upon E is equals to mu. So this is the velocity acquired by this your electron in this unit electric field. So that is also we will call as a mobility. So this mu, what we can say, it is about the mobility of your carriers. Yeah, so now along with that, so we have to see now, so this mu is equals to Vd upon E. Now we know the expression for your drift velocity. So generally we say that it is in terms of, that is a into tau. Yeah, so this a into tau, then again a is equals to f upon m, that is how we have written. Again E is equals to f upon q. So then definitely you can say that this q into E, that is tau upon m. Yeah, so this is how you can write it down, the drift velocity. So this mu is equals to q e tau upon m, yeah, upon E. So this E get cancelled, and this is how we can write it down. So this mu is equals to qt upon m. Yeah, so that is the expression for your drift velocity. So that is what I have written. So let's say mu is equals to this q tau upon m. Fine. So now there might be possibility that, so this is the mobility because of your holes, so which I will denote it, let's say by your P. Yeah, again q is equals to, we can say that it is nothing but E. So this is E, again let's say that is nothing but your tau. So this is tau upon mp. Similarly you can write it down for electron also. So the charge on the electron and proton which is same, and this is your me. Yeah, so that is what I can write it down. So definitely again I can write it down, definitely the current which is because of your holes as well as because of your, again that is your electrons also. So instead of this I will just write it down. So first let's say I is equals to, that is the IE plus IH. Yeah, and again I is equals to ENA. Yeah, so this is VD. Yeah, so this was nothing but the expression for your I, so which we have seen already. So I is equals to ENA into V into D. Fine. So again for this expression further we can simplify it. So let's say this total current again further, so this is ENA. So this is VD is nothing but your mu into E. So this IE, so again here I just write it down. So this is ENA, then this is electrons, and this is E plus again this is E, then again P, this is A, this is mu P, and this is E. So what you can take common over here? So you can see you can take common E, then you can take common A, then that is E, then further that is a N mu E plus your, instead of N obviously now it is P mu P. Fine. So this is the value for your current. So that is what you can say, the relation between the electric current and mobility for a conductor. Yeah, so that is what the expression we have written over here. So for this case, yeah, so for this case the same expression what we have got over here. So over here also, so I can just say that I is equals to EAE. Yeah, so I is equals to, that is a EAE, and in bracket what I have written, so obviously that is your number of your n mu e. Yeah, so this is a n mu e plus mu into, that is a p. So again further I know that I is equals to V upon R. So again this V is equals to, obviously I can just further simplify this, A is equals to V upon L. So that is your electric field is nothing but voltage per unit length. So you can write it down, this V is equals to your E into L. R is equals to, that is a rho L upon A. So L get cancelled. So this is actually EA upon rho. Fine. So this is what we can write it down. So I is equals to EA upon rho over here. Now I we know that, so that is a EA into E. So then again this further I can write it down. So this is your n mu E plus P mu P. So that is the value of your I, and then this is E into A rho. Fine. So this EA get cancelled. Yeah, so this is what I can write it down. So in bracket again further you can write it down. So that is a n mu E plus P mu P, and which is equals to again 1 upon rho. Yeah, and 1 upon rho, that is nothing but your resistivity, so which is nothing but conductivity. So sigma is equals to E into n mu E plus P mu P. So this is how we can write it down, the relation between this conductivity charge on an electron n mu E plus P into mu P. So that is what we call as a conductivity of semiconductor, where I'm just assuming that obviously both electrons and holes which are responsible for your conductivity. Yeah, so in case of semiconductor, in case of, we say that conductor, it has only free electrons. In case of electrolyte solution, both positive negative ions are there, but in case of semiconductor, both electrons as well as holes contributes to the flow of current. Although you can say the direction of your drift velocity, one is going in the, both are in the opposite direction. Yeah, so this is how you will get the expression for your conductivity of semiconductor.